Okay, Andy. Good morning, everyone. Online students, can you hear my voice? Say yes or no to me once. Yesterday, I given notes and I stopped it, I think. Equals methods. So today, let me write the programs based on it. Example program demonstrating equals. Right. So demo string 6 I'm taking. Import java.util scanner I'm taking. So read two strings like this. System.out.println. Enter the string 1. Enter the string 1. String sum s1 is equal to s dot next line. Enter the string 2. Two strings. It's 2. We are using equals method now. Equals method return type is Boolean here. Return type is Boolean. Where is this? Boolean. So here, some Boolean variable, we'll take P equal to S1 dot equals S1 dot equals of S2. I'm taking. If that P is true, strings are equal. If not, strings are not equal. You can say. You can say strings are equal. You can say. If not, you can say strings are not equal. You can say. Strings are not equal. You can say. The same way I am using ignore case also I am using. For output purpose, I am differentiating them. Equals method I am using. Now system.out.println. I am using equals ignore case I am using. Equals ignore case also return type Boolean only. PQ, right? Here I used P, I am using Q here. S1 dot equals ignore case of S2. Save. Here Q. So this is the structure anyway. So this is equals S1 dot equals of S2. If it is true, P is true means strings are equal. If not, not equal. Ignore case means it must not consider the case, whether it is lower case or upper case. It must not consider. It must check whether content is same or not. It has to check it. Now here I am using NIT. I'll use it. NIT. I'll use it. It will say strings are equal. It will say. I'll use NIT here. I'll use NIT. In the first case, equals method will say strings are not equal because equals method will check the case also, uppercase, lower case, separate. Because of this reason, our high level languages are case sensitive languages. Case sensitive means they will identify uppercase separate and lower case separate. So strings are not equal. In the ignore case, if you observe it, strings are equal, it is saying. Means what? It is ignoring the case and comparing the content. Content, NIT, both are same. Content. But internally, uppercase, lowercase is there. Uppercase ASCII value different, lowercase ASCII value different. Even then it is saying equal. The reason it is ignoring the case and comparing the content. All of understood ignore case? Okay. Suppose I given NIT here. NIT anyway, strings are equal. I given NIT here. I'll use space NIT. I'll use it. Space NIT. Space also character only. So this N will be compared with the space first. So both are not equal. Strings are not equal will come. So by mistake, if you enter any space before the string or after the string, you must remove them. For that, the other given one more method known as trim method. TRIM, trim. Trim means remove the spaces before and after, like this. After reading the data, you can use one method known as trim. You can use it. Trim method. You can use it. Dot trim. You can see. So trim means remove the spaces before and after. Now we run it. I am entering NIT space NIT. Now it removes the space and compare it. It will say strings are equal. All of understood trim method? All of understood ignore case? Right. Everybody should identify there is one method known as equals to compare the strings. There is one more method known as equals ignore case. Whenever I want to remove the spaces before the string, after the string, we had a method known as trim. So these are the identifications you done through this program. Demo string 6.java, and this is the output. Equals method output. Now let us write one program related to your compare to method. Example program demonstrating compare to method. Compare to method. Look here. Same pattern of writing here. I'll save as this program. Demo string 7. I'll save it. Now, two strings I taken, but I'm using compare to method. I'm using system.out.println. I am using compare to method. I am using return type is integer anyway. So I am taking some x is equal to, now int some value x is equal to s1 dot compare to of s. I am using. Now system dot out dot println. Here also compare to ignore case is available. Compare to ignore case available. Int y is equal to s1 dot compare to ignore case of s2. Now this compare to method is used for sorting techniques. I said no, greater, lesser, and so on. Here, if that x value equal to 0, else if x value greater than 0, else, right? If it is x equal to 0, you can say system dot out dot println strings are equal, you can say. Suppose x greater than 0, then system dot out dot println. Here, S1 is greater than S2. String is greater than S2 means they'll compare the ASCII values. If not, S1 is less than S2. The same kind of writing here. Here Y will come. Here Y will come. Right. Let me run it now. Right. All of you understood this logic? Means that way of writing you understood? Yes or no? No. You should remember that. Enter the string now. NIT and NIT. In both the cases, strings are equal. Okay, right. I will take NIT, capital letter NIT. You know, no? Lower cases will be greater than 97. Upper cases will be in between 65 to 90. So S1 is greater than S2 because ASCII value is there or not now. So run it. See there, NIT is greater than NIT. Lower case is greater than upper case. But here strings are equal. Why? Because it is ignoring the case and comparing the content and saying that strings are equal. Now, suppose I given NIT and NIT, it will be less than NIT. Here same. Suppose I given ABC, PQ, PQR I taken. Now ABC is less than PQR. ABC is less than PQR. Means A means 65. P means more than 65 or not mean greater than 65. All of you understood how comparative method? Says or no to me? I am asking repeatedly. The reason in all the batches I'll ask it. When the situation comes, they'll forget it. For me, in all the batches, the headache is coming for me. The situation will come one day. You take 7:15 batch, morning batch, you take it. That batch people also. Whenever I do sorting, correctly they'll forget it. They forget it already. Here. Can you see comparative method? These are all product codes. I sorted the products based on the code I done. 7:15 batch. I sorted the product objects based on the code. On that day, comparative method will come. How many of you remember me? They used to see very seriously at me. That technique you should know. Here only component introduction. Comparative one method is there. Part of string. Comparative method return type is integer. With the integer value is 0, strings are equal. That concept you should remember. You should apply when the situation comes. This is merge sort. I only done the merge sort on user-defined class objects I done. So when I am comparing the codes here, whenever I am comparing the codes now, that visual should come. Since SAR is comparing, that comparative method means return type one integer will be there. So we write Z value, I am comparing the code. Here addresses will be traveling. All of you got it right. Situation I am showing where it is used. But today I am introducing the component here. One method is there. The method will have this kind of behavior that I am introducing to you. Component introduction is going to you. The component I am not applying now only. When the collection framework will come, then come. Sorting technique, how I can do sorting technique on strings? Array not entered. Data structure not entered. Groups not available. How can I do sorting? But one method introduction must happen, no? Comparison method is there, equals method is there. Method introduction has been happened here. You have to wait until the multiple object comes. When it comes, you should not forget. So here, when it is equal to 0, strings are equal. Positive value greater than 0, S1 is greater than S0, S1 is greater than S2. If it is negative value, S1 is less than S2. These points you remember it. Remaining all I'll take care. If you remember minimum things also enough for us, you will understand what we speak. Right. This program I'll paste here for the introduction of your component. Demo string 7.java. Whenever you want to compare strings, we had two options available for us. One is equals method, one is compare to method. That's the information to you. Equals method return type is Boolean, compare to method return type is integer. Whenever I want to do authentication process, user authentication, entered user available or not, he is the user or not. This kind of logics if I want, right? I'll take equals method. I will take it. No, sir. I am a multiple objects are there. I must order them according to alphabetical order, according to codes, according to prices. If I want to order them, I must use one sorting technique. Whenever I want to use one sorting technique, I must compare it and change it. Suppose I given one 30 papers to you, roughly shuffled, numbers are there. I'll give to you and say that order it. What will do now? You'll be looking for page number 1, no? You'll take page number 1. You'll be looking for page number 2. You'll take page number 2. You look for page number 3. You'll take it or not now? One sorting is going no here. How you are taking page? How you are taking 4 now? Sir, I'll take one page. The 4 must be greater than this 3, no sir. I'm comparing or not now? That comparison will be equal or greater or smaller. That only compare to method. The method will support for your sorting technique. I made a statement to you already. I only will train the sorting technique to you, part of collection framework. Right. All of you understood this? String comparison. String comparison means comparing two strings. The concept we call it as string comparison. How you can do in Java now string comparison? I can do with equals method. I can do with the compare to method. But standby two methods I given to you. Equals ignore case also there. Compare to ignore case also there. In sorting technique, we never use ignore case. We use normal equals and normal compare to. Point. Right. Now, is equal to operator is there. Generally, is equal to is there. No, equal to is there. Okay, right. I'll take one program. Demo. String 8 I'm taking. Right. String S1 is equal to double quotes NIT. Now say how many objects are created here? One object created here. String S2 is equal to double quotes NIT. How many objects created here? In total, how many objects? How many? 1 or 2? String S3 is equal to new string of double quotes Hyderabad. Here, how many objects created? 2 objects. String S4 is equal to new string of Hyderabad. Now, how many objects created altogether in this? 4 objects are, 3 objects are, 2 objects are. 3 objects. system dot out dot println. I am comparing string literal process objects. String literal process. String literal process objects are there. No, I am comparing them. Equal to is equal to operator I am comparing. I am using is equal to operator I am using. So system dot out dot println strings are equal. Now system dot out dot println strings are not equal. The objects which are created by using string literal, we are comparing with is equal to operator, we are comparing. Now I am taking new operator process objects. Here new operator process objects are there. New operator process objects are there. Here S3 and S4. I am comparing S3 and S4 which are created with new operator. Right. Now see the answer. Two different answers will come. What is the answer here now? Strings are equal. Here strings are not equal coming. Right. Now FAQ. Can we use is equal to, can we use is equal to operator to compare non-primitive data type variables? Can we use is equal to operator to compare non-primitive data type variables? These non-primitive data type variables will hold references, no? Generally, correct. No. We must not use. No. We must not use is equal to operator to compare non-primitive data type variables. No, we must not use is equal to operator to compare non-primitive data type variables because the operator will compare object references and generate wrong results. It will not compare the content, it compares the address. No, we must not use is equal to operator to compare non-primitive data type variables because the operator will compare object references and generate wrong results. It compare object references and generate wrong results. Now, let me explain this program once, how two different answers are coming. Here, two different answers are coming here. Strings are equal, strings are not equal. Sir, what happened here? If you want to draw one flow here for this program, method area where classes are loaded, heap area where objects are created, method area, heap area, Java stack area. Execution starts from main only anyway. In this main, here also string literal process. Not string literal, sorry. String constant pool. String constant pool. Now, the first line. String S1 is equal to double quotes NIT. String S1 is equal to double quotes NIT. This is string literal process, no? Right. In string literal process, execution control will check the string constant pool. Is any object available with the same string data? So your object not available. When the object not available here, one new object is created. One new object is created with the string data as NIT. As NIT, one new object is created. Here some methods are there, you know already. ToString method and so on, you know. Once object creation completed, this reference will be loaded onto S1. Like this. After this first line completed, second line. String S2 is equal to NIT. String S2 is equal to double quotes NIT. Again, it is a string literal process. Execution control will go to string constant pool and check. Is any object having same string data available? No. Yes or no? Na? If it is available without creating a new object, it has to reuse this address. It has to reuse this address. It has to reuse it. The same statement I recorded to you already. The first day I recorded. In string literal process, the execution control will check the string constant pool. Is any object having same string data? If not available, then create new object. If already available, then use reference of existing object. Now S1, S2 having the same address. Yes or no? When the S1, S2 having the same address, Now is equal to operator will compare the address, not the content. Both are same means what is the answer here now? Strings are equal. The answer coming. So the answer is coming not based on the content. The answer is coming based on the address. That only. This is okay. Now go for the next one. New operator process is there for you. So here new operator process. String S3 anyway. Sir, new operator process. String S3 is equal to new string of double quotes HYD. I made a statement. New keyword is there means directly the object is created in the heap area directly. One object is created. While object creation, constructor is executed. Constructor is executed. While constructor execution, it needs parameter. Parameter is double quotes HYD. Double quotes is nothing but string literal process. String literal process means again it has to check the string constant pool. Is any object having the same data HYD? So here, object not available here. Understood this point or now? So when the object not available, one new object is created. One object is created with data HYD. Right, like this. Now this address is passed as parameter here. 0x4. When the address is passed as parameter, this constructor will take this address and bind here. Here some methods are there. That's a common. Now this address will be loaded to here. S3 will load it. Now S3 is holding this address. No, all of you understood this. How many objects created here now? 2 objects. Now after this one, string S4 is equal to new string here. String S4 is equal to new string of double quotes HYD here. So new operator will create one object directly part of heap area. While object creation, constructor is executed. While constructor execution, we have to pass HYD as parameter. Double quotes HYD means a string literal process. Go to the string constant pool and check is any object having the same data. Available? No. Yes or no? No. Available means reuse it. So this address is reused. This address is reused. And the address is binded here. Once the object creation completed here, this address will be binded to S4. S3 address and S4 address, both are different, no? Say yes or no to me. If both are different, answer is strings are equal, strings are not equal. Strings are not equal. All of you understood? Now is equal to operator, we must not use on non-primitive because it will compare the references. It may generate wrong results. So is equal to operator must be used only on primitive data type variables, integer comparisons, float comparisons, char comparisons, Boolean comparisons, you can use is equal to operator for string, for array, for interface. This kind of non-primitive data type variables, you must not use your is equal to. All have understood this question? Right. So here I'll paste that program here. Demo string 8.java. Two different answers are coming here. Followed by the diagram, I'll paste it. How the addresses are organized. You must use equals method or comparative method, but you must not use is equal to. That's the meaning. Okay, right. So before introducing some other methods, so major work we done. Okay, right. Java.lang.string class. Objects are immutable objects. Whenever I want to create object for java.lang.string class, I had two approaches. One is string literal process. One is new operator process. You know the differences also already. You can perform string concatenation. You can perform string comparison also. But string comparison, you must not do with is equal to operator. You must do with equals or compare. Got it right? Now, more flexibility will not be there with string objects. More flexibility will not be there with string objects. Java.lang.string class objects, because the objects are immutable. You cannot change it. Because of this reason, the author given a second option to you, string buffer. Make it. Second option given by the author is string buffer given. String buffer class is from java.lang package and which generate mutable objects. Which generate mutable objects. The advantage of string buffer is mutable objects. Mutable means you can modify them. String buffer class is from java.lang package and which generate mutable objects. Nothing but mutable string objects indirectly. Mutable string objects, you can say. We use the following list of constructors to create string buffer objects. String buffer objects. Public java.lang. String buffer. Public java.lang. String buffer of int. Public java.lang. String buffer of java.lang. String. So public java.lang. string buffer of java.lang.char sequence java.lang.string buffer. So there are four constructors related to string buffer. One constructor without parameter, one constructor int as parameter, one constructor string as parameter, one constructor char sequence. Now, I'll use this case one. Create object using string buffer without parameter constructor. The syntax: string buffer SB is equal to new string buffer of without parameter, means while object creation I am calling this constructor without parameter. I am calling. Right. Now, in this syntax, if I create object like this, one string buffer object created with the capacity 16 means in this syntax, if I use the syntax like this, one object created. One object created. Of capacity of capacity 16 characters. Means one memory created to hold 16 characters. Whenever I want to add some data to it, I want to add it. I'll use a method known as append. What's the method I'm using now? Append. By using append method, I can add the data to that object. Okay, right. Write it. In this syntax, the string buffer object is created with default capacity, 16 characters. In this syntax, the string buffer object is created with default capacity 16 characters. Default capacity created with default capacity 16 characters. Means initially one memory created where the memory can hold up to 16 characters. That's called default capacity. We use append. We use append method to add data to string buffer object. String buffer object. We use append method to add data to string buffer object. Whenever you want to add the data to buffer, we are using a method known as append. It's a meaning actually. Known as append. Right. Look here. I am taking string, demo string 9 I am taking. Demo string 9 I am taking. I am using the syntax string buffer SB is equal to new string buffer. So this is your constructor call, first constructor call. Now the object will have one capacity, system.out.println. Default capacity SB.capacity, this one. System.out.println. Here length of SB dot length. So capacity 16, length 0. 0 means no characters available. That's called length. 0, no character available. But the capacity is 16 means memory created to hold 16. Now you can add it. SB.append. You can do language. You can add it. I added how many characters now? 8 characters I added. Now system.out.println. So data in SB. I am printing SB.toString. Always the method is toString. Then you can display the capacity and length you can display. See there. Capacity will be 16. Length is 8. I added language now. Still, how many characters I can add now? 8 characters I can add. So add it. You can add because the object is mutable. You can add for the same object. Mutable object. Actually, many people string programs means they'll do string java.lang.string. More errors will come. You try with buffer. Error will not be there. Many people don't know buffer available first. Many people. When they gives any interview system test comes, they'll try with string class. All flexibilities will not be there with string. Because immutable, no? You cannot do. It gives problems. But if you try with the buffer, it is a mutable object. You can add it, you can delete it. You can insert it. All operations you can do. So SB.append I am using. Programming I am using. I'll use space also here. How many characters now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Already 8 is there now. 11 and this is one space is there now. 12. 12 plus 8 already there now. Total how many came now? 20. 20 means you crossed the capacity, no? The capacity has been crossed. Whether exception should come, if not, memory should be increased. Any one must happen. Suppose this bottle capacity 500 liters example. Right? This is half liter. If I can fill up to half liter, no issue. If I put more than half liter, water should come out. If not, bottle should grow. Something it should happen. Here also, memory should grow. If not, exception should come. See there. Exception came, memory increased. Memory increased. So here 16 became how much now? 34. Sir, what is this 34? It's one formula will be there. Double the capacity. Double the capacity means what now? 16 plus 16 plus 2. So double the capacity, add 2. To overcome the exception, the formula is double the capacity, add 2. That will be 34. Next capacity will be 34 plus 34 plus 2. How much will come now? How much? 70 will come. So point. All have understood this point? Right. Write that point. In this syntax, the string buffer object is created with default capacity 16 characters. We use append method to add data to string buffer object. When length crossed the capacity, then the capacity increases automatically at runtime by doubling the capacity and adding 2. By doubling the capacity and adding 2. When length crosses the capacity, then the capacity increases automatically at runtime by doubling the capacity and adding 2. Initial capacity is 16. Next will be 16 plus 16 plus 16 plus 2. The capacity will become 34. Then 34 will become 34 plus 34 plus 2. It will become 70 and so on. The capacity increases to unlimited. The following some important operations can be performed on string buffer object. String buffer objects. The following some important operations can be performed on string buffer objects. One is insert operation you can do. One operation you can do, delete operation you can do. And one operation is reverse operation you can do. Reverse available here. The reverse method available here. Right. Now you can do some insert operation on this object. you can do one insert operation on it. Insert operation I can do. SB dot insert. Sum. You can save an index value and you can insert it. 0, 1, 2, 3, 4, 5, 6, 7. You have to start with index 0, no? Right. 0, 1, 2, 3, 4, 5, 6, 7. So by index 7, I am adding some string here. Space Java. I'll add it. One space. I can insert by index. This insert operation you cannot do on string because it is immutable. You cannot do insert. Java. I don't E na. Where is that E? Okay. Here I must use 8, I think. 8 only, no? Right. Came roughly. Language Java programming roughly. Insert operation possible by index value. That's my intention. I want to do delete also. Means that operation support available. My intention is that. System dot out dot println. Sir, delete operation also available. SB dot delete. Delete from starting index to ending index. You can delete it. Starting index 8. Ending index 8. I entered Java, na? Space is there, no here. 8, 9, 10, 11, 12. I want to delete up to 12, means I must write 13. Whenever I want to delete up to 12, I must write 13. It will take less than that number, it will take. Let us see. So you can delete some string anyway. So delete operation you can do. Came or not know this? Delete. So the string you added, the string you deleted. So you can do insert operation, you can do delete operation. Even one character can be deleted. One character can be deleted. All of you observe this point now, right? So I can delete one character, sir, from here. Where is this? System dot out dot println delete char at. Even insert caret also available, right? SB dot delete char at. One index value you can delete it. Okay, right? Some I will delete it with 2. Delete by 2 here. So the character what is available by index value 2, it will be deleted. 0, 1, 2 deleted, no, hand deleted. Okay, right? You can delete it. So my intention behind this is on string buffer you had more flexible operations. Delete it, inserting and so on. These operations you can do bit easily. You can do. Reverse. So system dot out dot println. I am using reverse. SB dot reverse. Directly the will be reversed. Directly the content is reversed. This reverse method not available on the string object. Yesterday I asked you to do the palindrome, no? Right. Whenever you want to do palindrome, you must do manual. How many have you done? Because you have to compare this side, you have to compare this side, and that it looks very hard. Who tried it? So because method not there, no, but you have to try it. Because interview question is there. So find a palindrome of a given string without predefined method. Question is there. So you have to do manually. Yesterday reverse method will not work, I know. If you try, you must do manual only. Some for loop you have to take it and you have to try it. So today I am giving reverse method. Reverse method is there, easy only. Directly without any for loop, you can reverse it. Directly reverse can happen. See that. Reverse is happening or not now. So these are the remaining all methods it will support. What are the string methods are there? All support is there. But there are some specific methods to do. Insert by index, delete by index, and reverse methods. All of you understood string buffer object behavior, right? This is the first one. Here program. Demo string 9 dot Java. Right. Now I am going for second syntax. That is case 2. Case 2, create object using string buffer of int. Syntax. String buffer SB is equal to new string buffer of some 6, I will take it. If not 5, I will take it. Difference between above syntax and this syntax is, here I am not passing parameter in the first syntax. If you don't pass any parameter, the default capacity 16 will come. But here, sir, I only must specify the capacity of a string buffer object. Then you must give a number. If I say 5, the string buffer object created with the default capacity 5. If I say 500, the string buffer object created with the capacity 500. Like this, I can specify the capacity, make a statement. In this syntax, the string buffer object is created with the default capacity equal to the value passed as parameter while object creation process. In this syntax, the string buffer object is created with the default capacity equal to the value passed as parameter while object creation process. I'm passing one value here now. That value is nothing but considered as a capacity of this object. Considered as a capacity of this object. Right. Demo string 10 I'm taking. String buffer SB is equal to new string buffer of 5 I'm taking. Now system dot out dot println default capacity SB dot capacity. Now system dot out dot println length of SB dot length will be 0, capacity will be 5. Whatever the value I passed, that is a capacity. Suppose I passed 100 here, the capacity will be 100. So initial, it is created for 100. It's a meaning. For understanding purpose, I took 5 here. Add it. SB dot append. Add Java here. Java only 4 characters, no? So system dot out dot println data in SB dot toString SB dot toString. The capacity here. Data is Java, capacity 5, length 4. Suppose SB dot append space. How much will come now? 4. And this is how much? 7. Huh? 7 plus 4. Let us see. How much? 8 and 12. Total 12. Capacity correct is there? No. How now? 5 plus 5 how much? 10. 10 plus 2 how much? 12. Exactly came or not now? So already it is double the capacity and came anyway. Correct. Same formula, no? You understood no already? No difference. If I add more, it doubles again. So here, first case and second case, I am not passing any parameter. 16 is the default capacity. I want to create object by specifying the capacity. Whenever you want to specify the capacity, you are only giving the value here. That only concept. Write it. Program demo string 10 dot Java. Case 3. Create object using string buffer of string. I am passing string as parameter. I am passing. String buffer SB is equal to new string buffer of, I am passing one string here. One string as parameter. You take one space also here. Total 6, 7, 8. So length of that string is 8. Length of that string is 8. Default capacity 16. 16 plus 8 it will take. What is 16 plus 8? 24. Means the default capacity is taken as in 24 like this. In this syntax, the string buffer object is created with default capacity equal to 16 plus length of string passed as parameter. In this syntax, the string buffer object is created with default capacity equal to 16 plus length of string passed as a parameter. In the above syntax, the length of string is 8, 8 plus 16. So 24 is the default capacity. This discussion will help you for system exams. They will help you. That's about it. If not, if I want to close the session, I'll introduce string buffer, I'll run the program and I'll leave it. But I am individually discussing and coming so that any interview questions based on system test comes. By seeing the syntax, they'll ask a question. If you know there are 4 syntaxes available, you can answer it. But the discussion is going on. In normally, we use the first one, string buffer without parameter, and we do the work practically over. But this analysis for you for interview purpose only. Okay, right. Now see, I am taking this. I'll take 11. Here string buffer, I am taking space NIT HYD I am taking. First you must know the default capacity. No, see there. What is the default capacity now? 24. Already length available or not now? Already data is there. Sir, already data is there. So system dot out dot println data in SB already. SB dot toString already data is there. If you want, you can add it. SB dot append already data is there. Java language programming How much this? 4, 5, 8 are this one. How much? 8 and 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 came now. Right. 25 plus this how much now? 8. 25 plus 8 how much now? 33. It crossed the capacity now. Twenty-four plus 24 how much? 48. 48 plus 2 how much now? 50. Amla is coming or not? No. Doubling the capacity, adding 2. Write it. Program demo string 11 dot Java. Now, last one. Create object using string buffer. Here, char sequence. Char sequence means another object as parameter. Like this. Syntax. String buffer SB1 is equal to new string buffer of space NIT HYT. String buffer SB2 is equal to new string buffer of SB1. So one object holding reference of another object. So this syntax is used to interlink two string buffer objects. This syntax is used to interlink two string buffer objects. String buffer objects, which means one string buffer object is holding the reference of another string buffer object. Another string buffer object. SB2 object is created with the default capacity. SB2 object is created with the default capacity equal to 16 plus 16 plus 16 plus length of string available in SB1. SB1 length will come here and SB1 data will come. The data is available, the length is available. Data available means length is available directly. SB2 object is created with the default capacity equal to 16 plus length of string available in SB1. Length of string means this one 8. 8 plus 16, again 24 will come. Right. String buffer SB2. This is SB1. SB2 is equal to new string buffer of SB1. Right. We are printing SB2. 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 Default capacity of SB2. We are working with the SB2. See the capacity. 24 coming or not now? The data available in SB1 is coming to SB2. Because in string also that only, no, just now I drawn the diagram to you here. It's also same, no, here. Whenever this object available here, whenever I work with this object is working, no? Whenever I say S3 data is coming from here, it's interlinked and answer will come. Directly the answer will come. That only here. Directly the data is available to SB2. Moreover, the length is 24 because 16 plus length of this. All of understood the fourth syntax, right? If you want to create string buffer object, you had 4 options. That's the meaning of this discussion. How many options are there? 4 options. In practical, we use first one always. So remaining 3 options also available. You should know. Right. Small program only. Demo. String 12. Not Java. Okay. Yesterday I given some assignments, no? Right. How many of it tried that? Raise your hands. Right. Now take one assignment for today. Write a program to read a string and display the string without duplicate characters. Write a program to read a string and display the string without duplicate characters. Without duplicate characters. Understood the question, all of you? Suppose input str is equal to program. Duplicate available? Right, okay. Then the output is what now? P will come, R will come, O will come, G will come, R must not come. A should come, M should come. So duplicate must not be displayed. Again, R must not come. Remove the duplicate and display. Try this one. Tomorrow I'll write the solutions above. 1 2 questions are there, no? Solutions, and tomorrow I'll make string. What is this next one? Builder also waiting. We'll conclude it. Okay. Take a break. Some more methods are there. I'll introduce tomorrow. Remaining substring method, split method, some other methods are there. I'll introduce. Right. Take a break for today. Yesterday's notes updated. Thank you very much for today. Strict buffer object. Case 4 is another object is holding the reference of another object. Or I'll show clearly. Clearly.